Hello, this is the reading for week 6 for Physics 2211. This week, we were focused on breaking down the net force, velocity, and momentum into two components, the parallel component and the perpendicular component. A change in either of these values means an interaction has occurred. We first began by looking at how velocity can be broken down into these two parts, then discussing how momentum was really no different. Their formulas are structured the exactly same way. Delta V, or P, equals delta V, or P parallel, plus delta V, or P perpendicular. We also learned that we can use calculus to break down F-net into component forces. We represent these forces as delta P as a vector over delta T. Then we began looking at what the motion is doing if the parallel component is not equal to 0, but the perpendicular component is. We found that having a non-zero value in the parallel component causes the object in question to speed up or slow down, with a positive value being speeding up and a negative one being slowing down. It was mentioned also in the videos that there is one case of motion in that P initial parallel and P final parallel are in opposite directions. This occurs when the object reverses its motion within the time step, and we can think of springs as an example. Then we analyzed the other case. If the perpendicular component was non-zero while the parallel component was still 0, we found that instead of determining if the object is speeding up or slowing down, this determines if the object's path is curving. Interestingly enough, the value for how much it's curving utilizes what is called the kissing circle, a circle that runs tangent to that specific point on the object's trajectory. An alternate name for the kissing circle is the oscillatory circle. But since that sounds weird, we are going to follow the video's example and continue calling it the kissing circle. One of the main factors determining how much the object curves is the size of the kissing circle. Small, and the object is making a very sharp turn. Large, and the object is just barely switching directions. This topic was entirely new to me. I have studied calculus before, but I've never seen this application. However, it did make a lot of sense when explained in that way, especially with the kissing circles. Something that caught my attention when watching the videos was centripetal acceleration. I've actually seen that before in my high school physics teacher's class, but it was explained in a very different manner. We did not learn about the components of net force. We learned about it as basically one force altogether. This actually relates to my major, which is chemical engineering, through centrifuges. When looking at how a centrifuge works, a certain force is applied to cause the particles to spin and separate based on mass. Heavier particles go towards the back, so that in the equation n times the magnitude of the velocity squared divided by r, the larger radius can cancel out the effect of the increased mass, so that all particles can keep moving because there's only one force being applied. And noted, it does utilize the centripetal force, which really isn't actually a force according to the videos, not acceleration, but it's closely tied to it. The most difficult topic will be the glow script. The coding occasionally contradicts MATLAB, the other programming language I'm learning, which makes it a little confusing. However, there are plenty of resources to assist in figuring out glow script, such as an article written as an introduction to glow script for an Intro Physics 1 class, but it goes much further than a standard introduction. It covers vectors and creating arrows, all of which will come in handy for Lab 2. Another good source for GlowScript is the notes Dr. Aliseo put out as test review. That has a short review of various functions a GlowScript can do and how to achieve that in the program. Even if you're fairly confident in your skills, it would be a good resource to keep handy on the off chance you forget something basic. Additionally, a source on the kissing curves, because to a non-physicist, it doesn't fully make sense initially, is from a mathematics magazine. This was an interesting explanation to me as I do love math, and I would rather see something explained in theoretical terms than how it works in the real world. It's a fairly personal preference, but the article is well suited for my needs. So with that, reading week 6 is wrapped up, and see you all next week.